In this video, I'm going to show you how to solve the ALEKS problem called calculating partial pressure in a gas mixture. There are three different things you have to do in this problem. First, you have to calculate the mole fraction of the two gases in the mixture. You also have to calculate their partial pressures, and you have to calculate the total pressure in the tank. We are going to start by calculating the mole fraction of the two gases. For both of the gases in the mixture, we are given their quantity in units of grams. So the first thing that we need to do is convert these masses of each gas into moles. Dinitrogen monoxide is N2O. If you're not familiar with that, that's the kind of thing you can just look up on the internet. And we're going to use 14 plus 14 plus 16, 44 grams per mole. Of course, if you're doing this on ALEKS, you definitely want to use an exact molecular weight. You don't want to be rounding it. 14.6 divided by 44 is 0.3318 moles, and that's our moles of N2O. Now we're going to do the same thing for the sulfur hexafluoride, which is SF6. Again, if you don't feel confident about interpreting the names of these molecules, just use the internet to look that up. Sulfur hexafluoride is about 146 grams per mole. And again, don't round these when you're actually solving these problems on ALEKS. Use their exact weights. That is 0.02630 moles of SF6. Again, let's remember what we're doing. We're starting by calculating the mole fractions of these gases. The mole fraction of N2O is going to be the total moles of N2O divided by the total combined number of moles of both of the gases together. So I'm going to add that up real quick. These two gases together, total number of moles is 0.3581. And again, that's adding these two numbers together. So that's going to give me a mole fraction here of 0.3581, 0.9266. It looks like we want these to 3 sig figs. And also when you're doing these problems on ALEKS, you definitely don't want to be rounding any of your calculations at all. Like you just want to be using all the sig figs that you can. For the mole fraction of sulfur hexafluoride, we could calculate this by just simply taking 1 minus the mole fraction of dinitrogen monoxide, but it is a good idea to calculate it out just by hand. This is a way of double checking that we haven't made a mistake in our calculations. The mole fraction of sulfur hexafluoride is going to be the moles of sulfur hexafluoride, which is 0.02630, divided by the total moles, 0.3581. And that is going to be 0.0734. So there's the two mole fractions. Now we could use our mole fractions to calculate the partial pressure of each gas, but I think it's going to be easier for us to move on next to calculating the total pressure in the tank. For the total pressure in the tank, we're going to be using PV equals nRT, and I'm just going to kind of rearrange this. We're going to be using P equals nRT over V. For the total pressure in the tank, we're going to use the total number of moles, the total temperature, it's kind of weird to say it like that, and the total volume. The total number of moles is 0.3581, so this is going to be 0.3581 moles. We're going to use our gas constant R, 0.08206 liters, atmospheres, mole Kelvin. And the temperature, which says it's 18 degrees C, convert that to Kelvin, 291 Kelvin, 291. And again, this, because this is a total pressure calculation, we're using the total of everything, the total moles, the total volume. 10 liters, there's our volume. 10 liters, our Kelvin units cancel, our liter units cancel, our mole units cancel. When we do the math on this, 0.3581 times 0.08206 times 291 divided by 10 gives us a total pressure of 0.855 atmospheres. Now, the last thing that we're going to do here, I'm going to kind of shrink this up a little bit. The last thing that we need to do is calculate the partial pressure of each gas. The partial pressure of a gas, N2O, comes from the mole fraction of that gas times the total pressure of all of the gases combined. So we know the mole fraction of N2O, and we know the total pressure of the combined gases, 0.855 atmospheres. So that gives us a partial pressure for N2O of 0.793. 0.793. For the partial pressure of sulfur hexafluoride, we could calculate that by using Dalton's law. The partial pressure of this gas and the partial pressure of this gas has to add up to the total pressure. Same kind of thing that we could have done with the mole fraction. But just as a way of double checking our work, I suggest that we calculate the partial pressure just to make sure that we're doing all of our calculations correctly. The partial pressure of SF6 is the mole fraction of SF6 times the total pressure. The mole fraction of SF6 is 0.0734, and the total pressure 0.855 atmospheres. 0.0734 times 0.855 is 0.0628 atmospheres. And then just as a way of double checking our math, if we add up these two pressures, they should add up to this number right here. So we'll check that. I get a little bit of a different number, but I get 0.8557. So it's a little bit off, but that has to do with the difference in the number of decimal places here. So again, when you're actually doing this problem on ALEKS, don't round anything. Don't round molecular weights. Don't round anything because it'll throw your numbers off just a tiny bit. But these are the steps that you'll take in this particular order to solve this problem.